A little bit sad they didn't use a red cinema camera as the main camera, because then they would have 8K footage for a future Martian movie. Let's talk about the cameras on the Perseverance Rover that recently landed on Mars. You've probably seen, you know I like cameras, and I know you like them too. So this channel is all about photography, drones and cameras, and I thought it may be a little bit relevant, plus it's kind of fun to see what cameras they use on the rover that they sent to another planet. There are 23 cameras on this rover, of which 9 are engineering, 7 are for science and 7 are for entry, descent and landing. At first I thought, what's the difference between engineering cameras and science cameras? So because I have monkey brain, I googled what is engineering and what is science. And this is the result. Get it? Good. That means you get plus 10 IQ. But for those of you who have monkey brain like me, let me explain. Science is exploring the physical and natural world and getting the knowledge, while engineering is using that knowledge to make or maintain a product and maybe solve a problem. So in this case, engineering cameras are used for driving the rover around the Mars, while science cameras are used to take high quality images and video of the planet, shoot lasers to see what atomic elements the rocks are made of, and look really close at rocks. And also there's entry, descent and landing cameras, ADL, which are kind of self-explanatory. Let's start off with the engineering cameras. The engineering cameras are HazCams, hazard cams and navcams, navigation cameras, located at the front and the back of the rover. They are like the eyes of the rover that the certified drivers at NASA use to see where they're driving. Unfortunately, you can't drive this thing in real time, so there is 7 minutes lag, or delay as scientists like to call it, between the planets. Therefore, they need to plan their route beforehand and after watch it driving. So basically like a turn-based game. HazCams are mounted on the lower portion of the front and the rear of the rover. There are 4 pairs of them. They use visible light to make 3D images. Then the brain of the rover uses these 3D images to make decisions of where it should drive and what obstacles it should avoid. So basically it kind of thinks on its own. These cameras have an image size of 1024 by 1024 pixels, image resolution of 2.1 milliradians per pixels and a fisheye lens. But I didn't find which focal length it is, but I guess it's somewhere between 6 and 16, 17 millimeters or something like that. The focal length tells the angle of view. Shorter focal length gives a wider field of view and longer gives a narrower field of view, so it can see further. Navcams work together with HazCams, and these are the cameras that the scientists use to plan out their route. They give you a colored image compared to the black and white of HazCams. They are actually like our eyes, since they are placed on each side of the what I like to call the head of the rover, and same as before, they have 1024 by 1024 pixels image size, 0.82 milliradians per pixel, fixed aperture at f12 that gives them a field of view of about 37mm length on a full frame camera. There are 2 pairs of these cameras, 1 pair on the head, 1 in the front of the rover body and 1 in the back. And when all these HazCams and navcams work together, they can produce images that are 20 megapixels. That's basically what you get with today's average crop sensor DSLR, like the Canon EOS 800D, which has an image resolution of about 24 megapixels, so it's kind of close. And an iPhone 12 Pro has an image resolution of 12 megapixels. So the rover has much better cameras than the iPhone 12 Pro. I guess you should have bought a rover instead. Oh, and also there's one more engineering camera, which is a cache cam. It basically just records the sample collection. It takes picture of the samples rover collects before dropping them off for a future mission. The science cameras. Now we get to the fun part. There are 5 science cameras on this rover. A pair of Mastercam Z's, Supercam, Pixel, Sherlock and Watson. Mastercam Z takes color images and video of the terrain, and it has a powerful zoom lens that has a range of 26 to 110 millimeters. This helps scientists zoom in on the rocks, picking out some that might preserve signs of past life. They tells us which rocks to core, cache and maybe return to Earth someday. Mastercam Z shows us the entire scene around the rover. It can look around a full 360 degrees and look up and down full 180 degrees. Because there's a pair of these cameras mounted by each other with only 24mm distance between these two cameras, they provide a stereo vision and can generate 3D images. Image resolution is 1600 by 1200 HD format pixels, f7 at wide angle and f10 when zoomed in. When sending these images back to Earth, it has lossless JPEG compression and a speed with over 100 megabits per soul. And you might be wondering, what is SOL? Well, SOL is a Martian day. That means it sends about 100 megabits of image data per Martian day, which is 24 hours, 39 minutes and 35 seconds. Compare that to an Earth day, if you didn't know, is only 24 hours. So if you need more time, you should move to Mars. So depending on the image size, it can take days to transfer it from Mars to Earth. But luckily the rover has 128 megabytes SD RAM and 8 gigabytes flash buffer for each camera. So it can take a lot of images and video and send them at a later time. And if my calculations are correct, an 8-bit image 1600 by 1200 pixels is at least 1 megabyte. 1 megabyte is equal to 8 megabits. So to transfer the image to Earth, it would take about... So it takes about 2 hours to send an image from Mars to Earth, which is quite impressive if you think about the distance between these two planets, which is 54.6 million kilometers. Okay, next camera, SuperCam. Damn, who comes up with these names? They're amazing. It is used to analyze the chemical composition of the rocks and soil. So this camera basically fires a laser at the target and analyzes the vapor that it's made of. The SuperCam consists of many different components: telescope to focus the camera and laser, the camera to capture detailed images of what the laser shoots, the laser itself, and a couple of spectrometers for chemical analysis. It also has a microphone. Now we can finally know what the Martians sound like. Pixel. It's not the same as the Disney Pixar, even though in my opinion the lamp somehow reminds me of the rover's head. This camera is an X-ray detector, hence the name Pixel. Planetary Instrument X-ray Lithochemistry. It identifies chemical elements at a tiny scale. While the SuperCam shoots laser and analyzes the chemistry of the plasma vapor, the Pixel uses the rover hand to get close up to the target and shoot X-ray, to then use X-ray fluorescence to identify chemical elements. Pixel also has a camera that takes super close-up pictures of rocks and soil texture. It can see features as small as a grain of salt. Next up is Sherlock and Watson. Sherlock camera also uses spectrometers and lasers, but it's more specific to analyzing the textures of the surface to search for organic life. It's a black and white camera that is assisted by Watson camera, a color camera, for taking close-up images of the rocks and surfaces. That's about it for the scientific cameras, and I think they are really cool and advanced, and I'm really impressed with the technology of how they use all the different cameras to gather as much information as possible. Lastly, there's the cameras for entry, descent and landing, EDL. Not so much to say about them, except that they give scientists information about what happens in the EDL and give us a first-person view of the landing. That's great, since then I don't have to go to Mars. So to summarize, many cameras, super cool, highly advanced, impressive technology. A little bit sad they didn't use a red cinema camera or any other cinema cameras as the main camera, because then they would have 8K footage and maybe use it for a future Martian movie. But I guess they need to improve the transfer speeds before they can transfer 8K from Mars to Earth. Anyways, that's about it. Thank you very much for watching. I hope you enjoyed this video even a little bit. If you did, please subscribe and like this video, and I'll see you next one. Bye!